In the 7th episode of Factorisation, let's have a look at the sum and difference of two cubes. Now previously we've looked at dots, which is the difference of two squares, and there you only have the option of having the difference of two squares. So as we saw, there were two terms and they were both perfect squares and they were separated by a minus sign. So here again we have two terms each time, but this time they can be separated by a minus sign or a plus sign, and again in this case they have to be two perfect cubes. So how do we go about factorizing this? Well, in dots we ended up with two brackets each containing a binomial, and this time we're going to end up with two brackets, but one is going to contain a binomial and the other one a trinomial. So let's see how we go about doing that. First of all, the first bracket is very easy. All we've got to do is we've got to find the cube root of this term and the cube root of that term. So the cube root of 8 is 2, because 2 times 2 times 2 can give us 8. And the cube root of p cubed is simply p. And we keep our sign minus, and then we find out the cube root of 125, and that is 5. So there we've got our binomial bracket. Now we need to find our trinomial bracket, and the way that we do that is we take this first term in the binomial bracket and we square it. So 2 squared is going to give me 4, and p squared is going to give me p squared. The other way you can think about this, or you can check it back, is that you could be dividing that first term by that value that you've taken out. So 8 divided by 2 is 4, and p cubed divided by p is p squared. And that's a way you could also check back if you needed to. I'm going to go straight to the third term of the trinomial, because that one's also very easy. This term here will always be positive, because what we're going to do is we're going to take that term and we're going to square it. And when you're squaring a number, whether it's a negative or a positive, it's always going to become a positive. So 5 squared is 25. And then whatever that sign was, we're going to have the opposite sign for the second term in the trinomial. So that's an important thing to remember. And then how do we get the value of that second term? We simply multiply these two terms together from the binomial. So 2p times 5 is going to give me 10p. And that's basically as easy as it is. So let's have a look now at not a difference of two perfect cubes, but a sum of two perfect cubes. So again, we're going to start off by trying to find our binomial first. So the cube root of 27 is 3. And the cube root of x cubed is x, because remember, what we're actually doing there is we've got x cubed, and then we cube rooting it. And because cubing and cube rooting are inverse operations, they kind of cancel each other out, and you're simply left with the base number that you started with. Again, because that is plus, I'm going to have a plus in my binomial. The cube root of 64 is 4, and the cube root of y cubed, for exactly the same reason, is simply y. Right, let's look at our second bracket. So I need to take this first term and I need to square it. So 3 squared is 9, and x squared is x squared. I'm going to go straight onto my second term now, because we have discussed how to do it over there. So whatever this sign is here in your binomial, your second term is going to have the opposite sign. And then you're going to multiply these two terms together. So 3 times 4 is 12, and I have variables x, y. Remember, this term will always be positive, because when you're squaring anything, it will become positive. 4 squared is 16, y squared. Right, let's have a look at something a little bit more interesting. Let's look at 343 m to the power of 6 minus 27,000 m to the power of 12. Right, so 343 happens to be one of my favorite numbers. I do love the number 7, and it's related to that number. And the other reason I enjoy this number is because it's a palindromic number. In other words, you can read it forwards or backwards and you'll still have the same number. So the important thing here is that we've digressed from just having cubes as our exponents. We've now got different types of exponents. So let's go back to what we spoke about in dots with perfect squares. To find out if a power is a perfect square, you simply need to look at the exponent, and if the exponent is an even number, then that will be a perfect square. So let's look at another situation with roots. When we work with surds, and if we put it in root form like this, it's called a surd, we also learn how to convert a surd into an exponent. So my base number is x, and then because it's the square root of x, which is kind of implying there's a little 2 over there, we write it as x to the power of a half. So here we have an exponent which is in the form of a fraction. Likewise, if we have the cube root of x, then we would take our base number and it would be to the power of 1 over 3 because we're looking at a cube root. So the reason any even number exponent is denoting a perfect square is because we can divide that even number by 2 exactly without any remainders. So if we think of the cube root being x to the power of 1 over 3, in other words having an exponent of 3, that 3 denominator implies that you're going to need to divide by 3. You're going to be needing to divide by 3 exactly. So that's how we check whether these m to the power of 6 and m to the power of 12 are perfect cubes. Can 6 be divided by 3 exactly? Yes, it can, so it's a perfect cube. Can 12 be divided by 3 exactly? Yes, it can. And you should be recognizing that that is a perfect cube. I'm sure you're recognizing that 27 is a perfect cube, but now we've got 27,000. So let's deal with that when we get to it. So finding the cube root of 343, you should know that that is 7, because 7 times 7 is 49, and 49 times 7 is 343. To find the cube root of that, I'm going to need to divide by 3, so I'm going to end up with m to the power of 2. Whatever that sign is, I keep it in my binomial bracket. And now let's try to deal with this 27,000 situation. So again, let's just have a look over here. Remember that to find the cube root of 27,000, we're trying to find something times the same thing times the same thing again. So the best thing to do there is to forget about the zeros for the moment and look at the number 27. What is the cube root of 27? It's 3. So we know that these numbers we're multiplying together, which are the same numbers, each have to have a 3. 3 times 3 times 3 is 27. But then because we're having to split that between 3 factors, and I've got 3 zeros, it means that each of those is going to get one of the zeros. So let's double check back. 3 times 3 is 9, 9 times 3 is 27. When we multiply by 10, we put on an extra 0, another 10, and another 10, and that gives us 27,000. So the cube root of 27,000 is 30, and n to the power of 12 divided by 3 is going to give me 4. Right, let's start the squaring process. So 7m squared, all squared, is going to give me 49 m to the power of 2 times 2 is 4. Whatever that sign is, the middle sign is going to be the opposite. And how do I find this number? I multiply this term by that term. So 7 times 30, remember the easy way to say it is 7 times 3 is 21, but because it's 30, we're putting on a 0, 210, and then I have m squared n to the power of 4. The last term is always positive because we're squaring. So 30 squared, again, I'm going to say 3 times 3 is 9. And one of the 30s has a 0, and the other 30 also has a 0. And then n to the power of 4 raised to the power of 2 is going to be 4 times 2, which will be n to the power of 8. I hope that has been helpful, and it leads you into practicing some more examples, because remember, the more we practice in maths, it is a doing subject, the further we're going to get.